right, good afternoon. I guess it's sort of almost afternoon right now. So a few months ago, the program committee sent me an email and asked me, "Hey, Allard, can you give a talk about events?" I'm like, well, that's a particular broad topic, but yeah, I do know something about events, and I could talk about them. But actually, I prefer to talk about the fact that it's not about events. And okay, that's okay, you can do that, etc. And of course, now I'm here. And when I was preparing these slides, I thought, well, it's actually not even about microservices either. So what does that leave us if we take event-driven microservices, take out the events, and take out microservices? Well, driven is mathematically correct, but so we'll see where we end up. Let's see where we started first. So this is an architectural diagram that probably matches much of what you've built in, hopefully, the very far past. Unfortunately, I still come across this architectural style a lot nowadays, and a lot has been said already in this conference as well as others. And the big problem with an architectural style in which you define layers and then a domain model that is basically used by each of those layers is that you end up with a domain model that in some cases is anemic and in some cases is not. And then you map these services that you build to entities in that domain model, right? And I worked a lot on greenfield projects, and they're really lovely because you have this green field, right? Every mistake you make is yours. That's the downside of greenfield programming. But in the beginning, at least, the software is very elegant, and it's easy, and it's clean, and everybody understands it, because basically everybody is you and two colleagues, but everybody understands it. So you have these services, and they map really nicely to usually one of these entities in your model. And then a second service is built, and it still maps really nicely to that entity. And then there's that one feature request. And that service maps to more or less about everything you have in your model, because the model is not really suitable to do whatever that service needs to do in there. And I'm pretty sure you recognize this situation, or otherwise you recognize this. This is a perfectly normal SQL query that, fortunately, I did not have to write. Somebody else gave it to me to use in slides. And I had to make that person a promise. And that promise was that the attendees cannot read what's in the query. So usually the projectors are they were at the time relatively low resolution, so you had about 2 pixels per character. They were definitely unreadable. And then I used this slide in a presentation on a high resolution projector, and I was not aware of that. And suddenly I realized, oops, people can now read the characters. So I thought, okay, let's try to read the characters, and I still could not read the query. So I guess I'm still okay with my promise. You cannot read what's here. I think nobody can, even if you have it full screen. So I'll give you a little summary. There's 22 joins and 6 subqueries in this nice little SQL statement. Now put your hands up if you think this performs very well. Put your hands up if you like to work for that company because they have an open position for somebody to maintain this. All right. So what do we do if something doesn't perform? And we cannot fix it, right? We add caches or other technical aspects to our application. And in this case, I've exaggerated a bit. I've put caches all over the place and some worker pools because async makes stuff faster, right? Wrong. Caches are very poor problem solvers. They are very good at making something that works very well, make it work faster, but they're not very good at making something that works problematically. Not even sure if that is an English word, but if there's problems in your application, a cache is not going to solve that problem, right? It's going to hide it and make it explode even harder when things go really wrong. But the thing that struck me while creating this diagram, and I've been using the diagram for a while, is that all the solutions that we do are in the user interface layer, service layer, data access layer. But the problem, the real problem, is in the domain model. The domain model that we were using was not suitable for the activity that we want to implement in this application. So what we basically build is something like this. It is a perfectly aerodynamic machine that probably takes corners really fast. So this has all the characteristics of something that moves really fast, right? It has the spoilers, has the side skirts, but the core of the whole thing doesn't work. Yeah, well, it might work, but not as fast as we want to. And this is a typical caching problem. In software, we call this a big ball of mud. And this might be a revelation for you, but a big ball of mud is not really made of mud. So this is I guess a big bowl of goat smells and everything that we put together. And there's always a little architect sitting on top of it, proudly protecting its creation. So that's something we don't want, right? And I put microservices in the title of my slide, so I might as well talk about it a bit. So the idea of microservices is to split applications into smaller pieces so that they become easier to maintain and that our organization becomes more agile in the sense that if somebody in a suit has a nice idea, the dev guys can implement it a lot faster. We can move a lot faster, right? It also helps scalability, right? The amount of people you can have working on a single Git repository is limited, right? So if you split them up into separately deployable units, then okay, you can scale your organization much better. That's the promise, sorry. The problem is microservices are not easy. They're actually pretty hard. I mean, we fill conferences with talks about how to do microservices and how not to. And a lot of these talks focus on technical aspects. Fortunately, also a lot of talks focus on the non-technical aspects. And I think all the technology that we need, we can cover that. We can get there, right? We can find the tools that we need to do all of that. But there's something else. And it has to do with an observation by Martin Fowler, already quite a while ago, is that all the successful projects of microservices started with a monolith that was taken apart. And all the situations, or not all, but many of the situations where microservices were built from scratch, those projects ended up in trouble. In other words, they spent a lot of money and maybe never even made it to production. And that is usually not because of technology. I mean, the Kubernetes is something you can learn, right? You can find people to help you. That's all right. The problem here is whether we like it or not, the concept of noun-driven design. I'm not sure if Alberto is here, but I have to attribute this to him. He came up with this term while we were having a beer. I guess that's where weird terms come up. And he said, you know, microservices is actually pretty easy. You just do noun-driven design, and then you're all good. What you do is you take a document that describes what you need to build, find all the nouns, underline them. Those are your services. All the verbs, they're your API calls, and there you are. Of course, he said that jokingly. So this is basically the mathematical formula for noun-driven design. And of course, that's not the way you want to build them, but if you look in practice, when microservices are built from scratch, we do see that they end up like that quite often. So you end up with an order service, and a customer service, and a product service, an inventory service. The formal name for this is entity services. And basically what you've built at that point is a relational database schema using HTTP abstractions. Imagine that query earlier, but then with HTTP calls. What was it, 20 joins, 6 subqueries, something like that? Rather one of you than me, to be honest, but I guess you feel the same way. So with entity services, instead of ending up with this big ball of mud, and I'm afraid this is a diagram that you've seen multiple times already, you end up with a distributed big ball of mud. Well, is that going to make you any happier than the first situation? To be honest, I'd prefer the left situation than the right one. Now, I was involved in some of these projects that ended up in big balls of mud. And I don't mind making mistakes. Right? I love making mistakes because they provide you with a learning opportunity. And I love to learn, so what's wrong with making a mistake? But what I really, really hate is making the same mistake twice. Because it means you had a learning opportunity and you failed to use it. And I made some mistakes twice. And then I thought, I really need to find a way to resolve this. And I came across this concept that is now called CQRS. And at the time it was called Distributed Domain-Driven Design. It was a very vague concept that Greg Young presented at some conference in 2008 or 9. And the idea was pretty simple. Instead of making a single model for your application, you create a lot of different models for different purposes. And these purposes, you can split those into the commands and the queries. So the components that are responsible for processing changes in your application, you can split those from the components that are responsible for providing information of the current state of your application. And if you do that, you end up with two things, whatever that really is. So one part is responsible for commands and one for queries. And what you can then do is create different models focused on whatever the behavior is of that specific part that you want to use. And this also allows us to take, of course, skipping one step here. Of course, if you execute a command, then somehow you want any query to reflect the changes that the command has made, right? So nowadays, we would use events for that. If you are still in the 80s, you can use stored procedures or table triggers or whatever you like. But events are really, well, they're quite mainstream at the moment, either hype or not. You can call it whatever you like. But there is something to events that is really, really useful. And what we can now do is take into account these different non-functional requirements that we have in different parts of our application. Right? Because now we have modularized, if you will, our domain model. And if a part of our command model has specific requirements, for example, being able to handle 1 million transactions per second with a latency less than 10 milliseconds, you will treat that model differently than a model that handles 20 commands per second and has a latency is allowed a latency of about 100 milliseconds. Right? You want to focus the efforts on the parts that are harder, if you will. And also, we can now make a clear difference between the command model and how fast that should be and the projections. How up-to-date do your projections really need to be? Do they need to be consistent, or do you allow for some eventual consistency? That's a choice you have, right? So CQRS does not equal eventual consistency. It gives you the option to deal with it if you want to. So what does that have to do with microservices, you might wonder. So when I was exploring this concept of CQRS around almost 10 years ago, time flies, microservices weren't all out there yet. So I definitely did not have microservices in mind when working on CQRS. But in practice, we saw that a lot of the users of our framework, they use it in a microservices environment. So we started to find out, okay, why do you do that? What's the benefit there? And basically, you have to realize that a monolith is not the same thing as a big ball of mud. There is nothing bad per se in a monolith. Right? For one, it doesn't smell. You can touch it without washing your hands, etc. But more importantly, you can probably tear it apart, right? There's ways to tear a monolith. Well, there's ways to tear a big ball of mud apart, but let's not go there. So when you have an idea, and this is an icon I always use for a business model, right? You have an idea of something, some process that gives you money. That's the simple form of any business, actually. And you want to implement that using microservices. Now, what you can do is go straight that way, right? But we already said that's dangerous, and that is a way you probably do not want to go, because you end up not where you think you are, but in a distributed big ball of mud situation. So what you could do instead is, why not build a monolith, but then a structured one? Make sure that there is very clear internal structure that allows you, as time evolves, to start extracting some of these components and start to deploy them separately. And that is usually driven by non-functionals. It might be driven by team size. Right? The team is getting too big. We need to organize our code base slightly different so that one team can work on one part. It might have to do with the stability of one of these components. Maybe that blue component has exceptionally high memory use, and you want to isolate that from the rest so that if it crashes, it doesn't take the rest with it. It might be anything, right? Anything but functionality. And as time evolves further, you can extract more components. Right? Those who've been to my colleague France's presentation, you've seen this in practice, right? He gave a demo where he displayed this. If you haven't, I'm sure the recording will be published soon. And maybe you can even evolve your microservices environment to a serverless environment, right? That could be a next step in this journey. And we notice in practice that people that embark on this journey, they get stuck on the top right. Not because they got stuck not being able to advance, but they got stuck there not having to advance from there. So they end up in a much simpler situation to manage than the one they would have had if they went straight for microservices. And that's what I meant with, this is not really about microservices. It's about embarking on the journey towards microservices, not to have to do microservices, unless you have to. Now, the ingredient that allows you, or that is required to be able to go on this journey is what we call location transparency. And location transparency is the idea that two components should not be aware, two components that interact with each other should not be aware of their respective locations. Right. And that sounds easy. Well, it is actually pretty easy. And it starts with a good API design. Right? Getting your APIs right is the first step. Unfortunately, it's not the last one. And one thing that really helps is explicit messages. Just sending explicit message objects from one place to another, or events. So this is something that event-driven microservices have also discovered, or some people have discovered, and are using event-driven microservices. And basically what they do is they event all the things. So everything we do, everything we communicate becomes an event, because events are really powerful, right? Because the sender can just send an event, the recipient is not, it doesn't matter where the recipient is, right? And in this case, they're really decoupled both in space and in time. It doesn't matter where they are, or it doesn't matter whether they are there right now or at some point in the future. They will get that message sometime. Now, the problem with this is that everything becomes an event, and we are very good in our industry to go from way over there to, oh, that doesn't work. Let's go way over here. Oh, that doesn't work either. Then there's a new generation of developers, and they think, oh, these old guys, they don't understand. We should do this. And then the next generation comes, and here we go again. Now, this problem might be familiar to you as Maslow's hammer. Right? If all you have is a hammer, everything looks like a nail. And I was researching a bit of the origins, and I came across that there's it's called a Birmingham screwdriver. So apparently in Birmingham, they like to repair houses with a hammer. But sometimes you need a screwdriver, but basically, what's the difference? Just whack it. And if it doesn't work, whack harder. Now the problem with this is it sounds like a cocktail, right? It sounds like something you can enjoy in the evening. Maslow's hammer is not really a positive thing, so I don't really like that term. I wanted something that sounds like a disease. So why not call it Maslow's syndrome from now? And it is it's a nasty disease because usually you don't notice you have it, right? People around you might not even notice. It's the people slightly further from you that might know that you do. And it manifests itself by, well, people that have this disease, they build stuff like this. There's an order service, and there's another service that needs to know about ordered items, right? This is probably a quite common scenario. Now imagine, of course, services have their own database, right? They're isolated, that's good so far. And there's a way for these services to communicate, which is all fine. Now, the order service emits events to notify other components that something has happened, right? So far, no problem, this is all good. Except that the service on the right now needs to know which items are ordered. And there's some business rules that need to apply to all those events to find out which ones were ordered. Because an item is not ordered when it's added to the order. It is ordered when it is added to the order, not removed, and then that order is confirmed. Not extremely difficult maths, but I'm pretty sure you can imagine situations where it does get pretty complicated. So we need to copy some of the logic that is probably living in the order service and some of the meanings of the mathematics behind those events and the rules between those events to the service on the right. And it gets worse. So this is a scenario that somebody presented in a presentation, well, of course not here at GOTO, it was some small meetup. And you know, this is, we've got ultimate decoupling in our systems, and this is what we do. We have an order service, and it just emits an order created. It is not coupled to anything. Oh, that's great. And the shipping service picks that up. Okay, so there's the coupling, right? So the shipping service needs to know the fact that the order service is emitting those events, otherwise. So there is coupling. And it will send an inventory confirmed event to say that, okay, we've got the stuff that you sold. Oh, that's great, says the order service, and it emits a ready for payment event. The payment service picks that up, so the payment service is aware of the order service emitting those events, so there's some coupling there. And when the payment is complete, it says it's paid. And the order service is aware that the payment service emits that event, so there's a coupling from the order service to the payment service as well. And then the process goes on. Now the problem with this situation is that there is coupling, but the events, basically, they switch the dependency around. So instead of having a dependency from the sender of the message to the recipient, it's now just the other way around. But the dependency is still there. If you communicate everything through events, you will still have two-way dependencies. Right? And two-way dependencies are not your friend. And we need to realize that there's more than just events. Right? It is, well, in our case, we believe that there's 3 reasons why components want to communicate. One of the reasons is still events. It is you want to notify another component of a fact. Something has happened, and I will tell the world, and whatever they want to do with that fact, that's theirs. Right? It's a typical pub-sub situation. You just publish it and move on with your life. And whoever picks that up, whenever they want to pick that up, that's fine. But in some cases, you want to communicate to a component because you want to trigger a side effect. You want the state of the application to be different after the command than it was before. So in that case, you would send a command. Right? And commands typically have one destination, and they might come back with an OK or not OK, or maybe a small piece of data if there's some auto-generated values in there. Right? But it's not about the data returning. It's about the side effect that the command creates. And the other type of message is a query. Sometimes you just need information. Sometimes you just want to know what the current state of the application is in some form, right? And the query, you can have different routing patterns for those queries. A very typical one is the point-to-point, which is very useful if you have a single authoritative answer to your question. Right? If you have a simple web shop, you say, what is the price of that product? And it comes back with the price, and that's it. But you can also do more complex routing strategies where you say, well, we don't have a simple web shop. Our pricing engine is actually pretty complex. And there's different rules that we apply to come to different prices. Like if you're a member of the exclusive club, whatever, you get a 10% discount. Or if it's the temperature is above 30 degrees outside, we'll reduce the price as well, or increase, depending on what it is you sell. So in that case, you can do a scatter-gather query. You can send a message to all the components that potentially have an answer for you. You can gather the answers and do a reduction function on it to get back to a single result. Right? And that's a very powerful principle because you can change the behavior of your system by not changing any existing component in your system. You just add a new component to provide a different answer, and the system will behave differently. It's both powerful and scary, if you ask me. Now, if we do that, we can redesign that, the problematic scenario from earlier, and we can reduce the coupling in logic, or the copying of logic on the right, by saying, well, if there's an order confirmed, that is still a notification that is useful for the need-to-know ordered items. It can do a query. Right? It can just go ask, okay, what are the details of that order? Because then I know from that object that I get back, I can iterate through all the items. I don't care what the order has looked like before it was confirmed, but as soon as it is, I want to know what it looks like. And let's have a look at the other scenario. So the order service, instead of emitting an event, it could just accept that there is a dependency of the ordering process on shipping. I don't think anyone can explain the exact ordering process without mentioning shipping. Right? So it's fine to have that dependency. So why not have the order service say, well, I expect this inventory to be reserved to make sure that I can actually sell it. Right? Then there's an event coming back. Now the dependency is now fully from order service to shipping service. Shipping does not need to know about order service. And the order service can send, well, I need you to perform a payment now, because that is really what I expect. Right? And it can say, well, the order was paid, ship order, etc. So now the dependencies are not two-way anymore. They're just from order service to the other two. Right? And in this situation, that might be good, might be bad, I don't know, but at least they're one way. And if you want to model them in the other direction, you can still do that, but then by choosing other message types. There is one thing about events, though, that makes them somewhat special in comparison to the commands and the queries, in that events retain value. The fact that something happened someday is valuable for longer than just when it is emitted. Right? When a command has triggered its side effects, well, the side effects might be important because they're events, typically. If you do a query, basically, if you've got your response, you don't care about the question that much anymore, right? The typical 42 problem, I guess. Yeah. So there's the concept of event sourcing, and event sourcing is very often correlated to CQRS. They are two independent concepts. You can do CQRS without event sourcing. You can do event sourcing without CQRS. And then you can do both of them regardless of whether you do microservices or not. So just imagine this order service, and there's another service that does some really smart analytics. So it needs to know everything that happens so it can be really smart about what was happening. Now, each of those services would have its own database, and they would both have their own model, right? The way they update their data internally. And this order service will emit events as things happen to that order. So far, this is not event sourcing. Nothing that is happening here is event sourcing. Right? This is just, well, it's already quite interesting, but it's just event processing, which is different. It becomes event sourcing if the order service itself uses the event it's generating as its own source of truth. That is the only way you can guarantee that all the behavior that the order service is showing is based on all those events. And everything that happens results in an event, and if something is not shown as an event, it did not happen. It's sort of, I swear to speak the truth, the whole truth, nothing but the truth, right? It's the three elements that you need to be complete. So instead of having a model, that order service would just store its history. It would just store all the steps that it took to get to the current state. And that way you can guarantee that everything you emit is true. And that last ingredient, that is essential. That's the essential difference between event processing and event sourcing. And for event sourcing, you need some way to store those events, which is typically done in event store. And an event store has some very typical characteristics. And I read a lot of blogs about, hey, we're using technology XYZ, and or we do event sourcing using tech XYZ. And that's great. And I sometimes know tech XYZ, and I know event sourcing, and I wonder, that's not possible. That technology cannot do that. And quite often they do event processing and not event sourcing. So the event store, what it needs to do, it needs to be able to efficiently append events, right? And in doing so, it has to be able to validate some sort of sequence in those events. And that is not a global sequence per definition, but there is, within any service, and in my example I've used order quite a lot, within a single order you will have consistency requirements, right? You cannot confirm an order that was cancelled, for example. If you have those requirements, you must be able to ensure that there is no order cancelled event, order confirmed event after an order cancelled event. Because there is a rule that says that cannot happen. So you do not want to execute commands concurrently on the same order. In this case, order would be an aggregate in terms of domain-driven design. Another thing that an event store needs to be able to do is a full sequential read. So some of these projections, they will want to read every event that comes by and update their projections, regardless from which order they came, right? But if we read a single order and want to apply something new, we want to be able to very quickly read the events that that order emitted in the past so we can recalculate its current state. And yes, there's some caching options and snapshotting that you can do to make that fast. So you don't have to read millions of events just to get to the current state. So you want to be able to find those events that were emitted by that order so you can really quickly recalculate that specific order state. And that is the required ingredient to ensure the correctness of all the events that you produce. So basically, and this is, when I wrote this slide, I thought, well, do I really have to say this? But I'll just say it and you can ignore it, or say, I knew that already. But the step is, well, if you consider these explicit messages, first of all, you want to then define, okay, which routing patterns do I want to apply to these messages, right? Do I want to use pub/sub, or do I choose a single destination or multiple destinations, etc.? And then you choose a technology. And a lot of us go for technology first. Like, oh, that's cool tech. That's the Maslow syndrome. I like the tech. Now I'm going to find some solutions or some problems that I can bang this on, right? And it will probably work in my little lab environment, and I'll blog about it and say, hey, we use event sourcing on Kafka. Be careful. So at Axon, we like this evolutionary approach, and we've accidentally built this framework. If you want to hear the full story, you can come up and find me. I'm usually around our booth downstairs. And that works. Axon Framework is an open source framework for Java, and it really helps to build this structured monolith and make sure that that communication happens. And it allows you to split that application into two parts, but now we have a gap between the two that we need to fill. And as I said, look at the routing patterns and then choose technology. So you could, for example, choose MySQL as an event store. Right? Beside specific technology focused to be an event store, we have found that a relational database is the best second place you can get. So before looking at NoSQL, just look at the old school SQL. So there's components that allow you to integrate that with the framework. And then you can, for example, use Spring Cloud Netflix with Eureka to do some discovery between the services. And then you can use HTTP to send commands. Right? Commands have a single destination, and a discovery service allows you to find a destination. So why not? You can use that if you want. Sometimes you want to publish events, not through an event store, but through something else. Well, they follow the pub/sub principle, so you can use RabbitMQ, for example. RabbitMQ works with exchanges and queues. You publish events to an exchange, and you read them from the queues. And every application would then get its own queue, so that they each read their own copy of the message. Right? Simple so far. Let's take the next step. Now we extract another service. So now what do we need to do? Well, we need to hook that into the existing components and then create a new queue for that application. This becomes quite complex over time. And this is how, well, sort of Axon allowed you to build applications for quite a while now. And we thought, well, there has to be a better way. There has to be some way to reduce that complexity in the middle. And we thought, well, basically, if you look around, there's different types of messaging systems, right? And you could put them on a scale of how smart they are in terms of understanding the messages that they transport, right? So it's not a positive and a negative thing. It's just how much of the message do they understand. So on the smart side, you would have an ESB. ESBs understand exactly what they carry. And as a result, you get, in companies, you quite often get the ESB department that tells you exactly what you need to publish so that they can do all the transformations and make sure everything works for them. That didn't quite work out the way we hoped in most enterprises, or in many enterprises. So we go to the opposite, like we do quite often. We go to a message broker, the dumb pipes, right? You just put a message there. The message broker has no clue what it is transporting, and it just publishes it to whatever queue that is connected to that specific exchange. They're much simpler, easier to maintain, often perform a lot better as well. And we thought, well, that's not ideal either, because commands and events and queries, they have different routing patterns. You don't just pub/sub all these messages. So what if there is an ideal middle ground? What if there is a system that just understands the stereotypes of these messages, not the payload, doesn't understand what the message means, but just knows, okay, this is an event, so this is pub/sub. This is a command of a specific type, maybe a name or some identifier, that you know, okay, we can route that to that component because it said it can handle those commands. In that case, we could replace that by this. In theory, right? We like simplicity. So we had a dream and we looked at it and we couldn't find anything. And then we realized, well, there's this idea that we have of evolutionary microservices and how important commands, events, and queries are. So we started looking if there's any technology that could help us with that. Either we didn't look good enough, but we didn't find anything. So that's what we started out building. And the way that works is, basically, a component just says, this is what I can do. I can handle these commands and I can handle these queries. And with these, I just mean a name, just some type identifier. And if that component there says, well, I want to get some order details, so I'm going to put a query, and that system in the middle would then magically, quote unquote, of course there's no magic involved, I promise, route that to the component that has said it can provide that query. And also, Axon Server is a product that we've built, which is open source and freely available as well, if you like to play around with it. Now, if we scale it out, if we extract that component, basically, it just changes the abilities of these specific components. Each component will still say, hey, this is what I can do. I can create an order, I can confirm an order. And the other one says, I can give you some order details. And then the routing system would know, okay, I need to get that query to that component up there. Right? Nothing in the configuration of the component on the left has to change, nor in the middle. Right? This is just all operational, volatile data. this is all good and fun, and this will work in a laboratory. No problem. You can do microservices on your local dev machine really easily, and it will work. You'll understand it, probably, and there's no problems there. But at scale, things work differently. And this is at scale of massive rollouts of microservices or large teams, or especially the combination of the two. So how do you route all these messages to all these components? Right, how will that scale? Well, the simple answer, this concept, just like that, does not scale. Right? Not for technical reasons, for non-technical reasons, actually. What you get is an unmanageable mess. So imagine all these components being able to talk to each other. Now, this component is a shipping module, and it wants to know when an order is placed. That is the language that the department there uses to express an order, right? It's placed, and then we do our work. That is not the language that they use in the order department. There they're talking about, no, it's not that easy, right? An order just doesn't get placed. There's much more to it. It gets created, items are added, items are removed, shipping addresses are added, billing addresses, etc., and then it's confirmed, right? And probably confirmed is what you call placed. Now, again, we get this copying of logic, right, from one place to another. You have to understand somebody else's language to make any sense in your own component. And you have to realize that everywhere where you have communication, you have a contract. And especially with events, that's problematic, because you send out an event, which means you have a contract with a component, or many components, because it's pub sub, but you don't know which ones. Imagine being married, but not knowing to whom. The only thing you know is probably more than one. Well, the idea scares me, to be honest. So leaving the house, not knowing for sure whether they expect you to clean the dishwasher or vacuum the floor, or maybe both. I don't know, that's horrible. So fortunately, there's a concept of bounded context. And I do not want you to read the entire text, because that's really boring. So a bounded context is a boundary around a natural language, sort of a part of the ubiquitous language that you have in an organization. It is the place where a specific word has a specific meaning. And outside that boundary, that word might have a slightly different meaning, right? And that's perfectly fine. It doesn't mean that one word is wrong and the other one's right. Things just mean different things to different people. And that's all right. That just means that you have a different context. So within a bounded context, and whether these blocks mean microservices or they mean component in a monolith, it does not matter. What matters is that when you share an event, it's safe to share it with those that understand your language. Right? If you listen to events, then it's fine to listen to events that are expressed in your language. Be careful when sharing events outside of your context. You might want to use a different language, because you do not want this marriage with unknown components outside of your intimate, direct environment. So you want to share more consciously there. So imagine we have these two components again that one wants to know when an order is placed, and one is emitting all these other events. And again, in domain-driven design, there's this concept called anti-corruption layer. And that's basically what this is. An anti-corruption layer, in this case, transforms the internal language to a language that can be used outside. Or in some cases, the language that you use from the outside, you transform it to something that is more comfortable to use for you in the inside. So in this case, it could be a little component that says, well, I'm going to listen to order confirmed event, because that is an important event, right? Every event is important, but this one is slightly more important. We sometimes refer to those as a milestone event, right? Something really important has happened. And then I get the order details, and I create this nice event that says, here's an order placed. And maybe they're more coarse-grained, maybe they're just carrying identifier, that's all fine. They're all different ways to address this problem. So we're running out of time. I'll do a small, very short recap. Events are useful, very useful. But we should not forget about other reasons for communication. And we should also not forget that these events retain value. They can carry value over time that we can use later on. By modeling messages explicitly, we can stimulate location transparency, but beware of your marriages and consider bounded context in those cases. And lastly, and I'm not the only one saying this, evolve your way into microservices. Don't just go there straight away. And with that, I think we have about 2 minutes left for questions.